In this video, we're going to be doing a part 2 of multiple choice questions for Unit 1 Kinematics of AP Physics 1. So we have a boat moves east at 5 meters per second relative to the water. The river flows south at 3 meters per second. What is the boat's velocity relative to the ground? In order to do this, we are going to have our Vx component equal to 5, and our south is going to be negative. This is going to be positive. So our Vy is equal to a negative 3 meters per second. In order to find the velocity, you are going to have to take the Pythagorean theorem of the x component squared plus the y component squared. The velocity will give you 5 squared plus negative 3 squared, which is equal to the root of 25 plus 9, which is the root of 34. And we can tell that our direction is going to be in the southeast direction because we are going to be going downwards that way. So actually, we are going to be starting here. We go 5 meters per second first to the east direction, and then we go downward. So that means our vector is going to be a resultant of this way. So that is our southeast direction. Now our answer is going to be option C. That's square root of 34 meters per second in the southeast direction. So the ground velocity is going to be the sum of the boat velocity and the river velocity. So this was the boat, and this was the river. And our V was our ground. A plane aims directly north with airspeed of 200 meters per second, while wind blows east at 150 meters per second. What is the direction of the plane relative to the ground? Well, we're going to have components. In the north direction, we're going to have 200. In the east direction, we're going to have 150. Since we have both components, we know our force is going to be diagonal, and that's going to be in the northeast direction. So first, we have up 200, and then this way. Our resultant vector is going to be this. Now, how can we find the direction? Well, our direction is going to be northeast. A swimmer wants to go directly across a river flowing east. What must they do? So if currently in our river is going to be pushing our swimmer to the east direction. In order to undo that east direction, the swimmer must push against the river and go to the west. So the swimmer must go upstream because downstream is what the river flows. So your answer is B, to counter. So two cars move perpendicular to each other at 6 meters per second and 8 meters per second. What is the magnitude of their relative velocity? Well, in order to find relative velocity, you're going to take the magnitude. So we have 6 meters per second, and that's going to be perpendicular to 8 meters per second. So to find the relative velocity between each other, that is going to be 6 squared plus 8 squared. Square root of 36 was 64, and that's equal to the root of 100, which is equal to 10. A ball is thrown horizontally from a 20-meter cliff. How long is it in the air? Well, our vertical motion is going to depend on time. We're going to be able to use one of our kinematics equations, which is x is equal to x initial plus v initial t plus 1/2 acceleration t squared. X is going to be the final position. Now, we have free fall in this scenario. When we have free fall, we are going to have our y initial is 0, our v initial is 0, and acceleration on Earth is going to be gravity for the object acting downwards. So if we apply all of these, we're going to be left with, instead of our displacement, we're going to have vertical displacement. So we can say that we have a y. That's going to be y is equal to 1/2 gt squared. Now, after this, what we can do is plug in, but we need to solve for time afterwards. we have that we travel 20 meters off the cliff, which is the vertical direction. So that's 1/2 gt squared. But we have to solve for our t. In order to do this, you're going to multiply both sides by 2. After that 2 cancels out. And over here, you're going to divide both sides by g. And you can also take the square root of both sides. So then you're going to be left with t is equal to the root of 2h over g. Now, after this, we can see that our time is only going to be dependent on our vertical motion, because in our equation, our horizontal velocity canceled out. So we can write a note for ourselves that time depends only on vertical motion. Now for our next question, a ball is thrown horizontally at 10 meters per second for a height of 20 meters. What is the horizontal range? Well, we know that we have that time is equal to 2h over g. Our horizontal distance is x is equal to vxt, x is equal to 10, which is our horizontal velocity here, times time. And our time is equal to that 2h over g that we have right here. Now, this is our expression that's A. So range is equal to the horizontal velocity times the time of flight. That is your range that you traveled. A projectile is launched at an angle theta. At the highest position point, what is going to be true? So this is going to be at theta. Now, what do we know is true? Well, when you're at the very top, your Vy is equal to 0. Your Vx is not going to be equal to 0 because that that horizontal velocity is going to be the thing that will keep you moving. So that cannot equal to 0. But your acceleration is still going to equal to g downward. So your vertical velocity is going to be 0 because it's transitioning from going up direction to the down direction. A projectile is launched upward at 30 degrees. Which quantity remains constant throughout the motion? Well, our horizontal velocity is going to stay constant. Vertical velocity is going to change. Our acceleration is going to stay constant, g. So that means that we have both our horizontal velocity is going to stay constant, and we are going to have, that's going to be our answer. So speed does not stay constant, your position changes, and your vertical velocity is changing as well. Now, a projectile lands at the same height it was launched. What determines its time of flight? Well, time for vertical motion is equal to 2 Vy over g. So Vy, which is inside of our equation, is going to be calculated by taking v sine of theta. So that's the vertical component of velocity. A projectile is launched at 20 meters per second at 30 degrees. What is the initial vertical velocity? Well, what we can do is we have Vy is equal to v sine of theta. If we know Vy is equal to 20 sine of theta, and we have 30 degrees as our theta, and our v is 20 meters per second, we can solve for Vy. So sine of 30 is going to be when you are here, and you're going to have root 3 over 2, and you're going to have 1/2. So your y position will be that 1/2. That'll be 20 times 0.5, which is equal to 10. And your answer is going to be A. Now, for our next question, we have a projectile is launched at 45 degrees. At what angle does the velocity point halfway through the flight? Well, when we have projectile motion, we always have this parabola shape, and we are going to be launched at 45 degrees. In this case scenario, we're going to have the same launch and the same ending height. So and we also know that our projectile motion is going to be symmetric. So at the highest point, your vertical velocity, we already know, is equal to 0 due to it changing direction of the velocity. So our velocity is going to be purely horizontal at this point. Therefore, our angle is going to be equal to 0 degrees. Because at our midpoint, you're going to have a Vy that is going to be at 0. And that's just going to not exist. And then your Vx is going to be equal to something else. So that means the angle is going to be equal to something that is horizontal. Your velocity is just horizontal. A projectile is launched at an angle and lands at a lower height. Compared to the same height landing, its time of flight is going to be what? So your vertical motion can be described with y is equal to vyt minus 1/2 gt squared. Now, if you land lower, that means that your object travels an extra downward distance. And it's going to take longer time. For example, you just have this, but if you have a building, you travel that same arc, but you also have to go down as well. That's going to be time as well. So that's time 1, time 1. This is going to be a time 2, that's more time. So that will take longer. A ball is thrown horizontally from a moving car. Relative to the ground, its path is going to be what? Our car is moving, and we're going to throw the ball. And our ground is here. Well, our horizontal motion, we're going to have a Vx horizontal motion that is going to be constant. Now your Vy, or let's just say horizontal motion, we have a V that is going to be constant. And then in our vertical motion, you're going to have an acceleration that is going to be downward equal to g. Now, if you combine then you're going to have a curved path. That's going to be a parabola because our independent motions will combine to be that shape. A projectile has 0 horizontal velocity at some point. What must be true? Well, a projectile, you're going to have your vertical or you're going to have your horizontal velocity equal to something that is constant. So if it was 0 at any time, if Vx was equal to 0 at any point, that means it was Vx equals 0 initially. Therefore, that means your object was actually never thrown in a projectile curve. Instead, it was thrown straight up because your horizontal velocity can't change unless it was 0 from the start. A ball is thrown upward from a moving train. relative to the ground, it goes straight up, and then down, relative to the ground, its path is going to be what? So we're going to have the train, right? And our train is going to give the ball horizontal velocity. Now our vertical motion is going to go up and down. So if you have up and down and Vx, if you combine them, you'll get a parabolic path. So that's going to be C. So from our ground frame, we get a parabola. Two projectiles are launched at the angles 20 degrees and 70 degrees with the same speed, which has a larger maximum height. Well, our max height is going to depend on our Vy, which equals to V sine of theta. Now sine of 20 degrees is going to be less than sine of 70 degrees. As you can see on the unit circle, when you're at 20 degrees, you're going to be at a lower height than if you were at 70 degrees. Now, that means that if you're at 70 degrees, you're going to have a larger Vy. And that's going to mean that you are going to have a higher max height, because when you multiply by a consistent V, like for example 1, what's going to be the differentiating factor is this sine of the angle. So if you have sine of, for example, 90 degrees, which is 1, versus sine 0 degrees, which is going to be 0, obviously if you multiply by the 1, it's going to make the number larger. So your answer is going to be 70 degrees makes your max height larger. A projectile's horizontal velocity is doubled. Its range becomes what? Well, our range is Vx times t. And this is going to make us see that, or this is for our range, but our time, it depends on our vertical motion. But our time, or our vertical motion, this doesn't change. So if our vertical motion doesn't change, and we have our Vx is going to be doubled, we're just going to have a twice as large range, because r is directly proportional to Vx. Now, a projectile is launched from a height h. What affects the time of the flight? Well, our vertical motion is going to determine time. Y is equal to Vyt minus 1/2 gt squared. So we can see that it's dependent on our initial vertical velocity, our gravitational constant, and also we're dependent on our height. But we don't have horizontal velocity. Now, that means that we have only B. Only vertical motion affects the time of flight. A ball is thrown upward at 20 meters per second. Another is dropped from the same height at the same time. Which hits the ground first? Well, if you have your dropped ball, you're going to have that fall down. So it immediately falls. However, your thrown ball, it has to go up, then it has to come down. So obviously that's longer. The dropped ball touches the ground first. A projectile is launched at a speed v at an angle theta, which expression gives the horizontal range. For projectile range, it's v squared 2 sine 2 theta over g, so that's just c.